And yesterday, in our class of corrosion, we talked about the different methods to check leaks, no? And one of the methods is with the amps, other method is with the ohms, and you know the process is disconnect the positive of the battery and install in series your equipment, your ammeter or your own meter, and check what is the magic number in amps. 1 milliamps. With 1 milliamps, with everything off, no? Everything off, but the breakers are on. Okay, you disconnect the positive of the battery, you insert your ammeter in series. I have more than 1 milliamp. That's not good. You have a leak. How is the leak? If everything is off, why I have a leak?
Short to ground, maybe?
Excuse me?
Short to ground somewhere?
Yes, it's basically because the equipment, for example, suppose the pump, you remember the fuel pump in the previous board? The pump is connected to the source of power, but the main breaker of the pump is off. The pump is not running. But for some reasons, because the power is entering, the motor no start, but for some reasons, the switch, the switch of the pump, have a little contact. And that pass a small amount of current. That small amount of current is not enough to start the motor, but it's moving, it's flowing, and it's leaking, no, into the ground. You understand? That small amount of current is not enough to start the motor, but it's moving, You have different type of sensors. We have here another sensor.
It's the WEMA.
This one, no, with this.
That's the better one.
And it's exactly the same. You have a pink and black. Black is the ground, and the pink in the signal, no? According with the level of the fluid, you have, yeah, this one or that one. How you check those sensors without power?
You disconnect.
You check between this and this what?
Check the resistance.
Resistance. And you move it, no? Oh, more ohms, less ohms, more ohms, less. Oh, it's good. My sensor is good. The same like this. You check between this and this, and you check with no power, more and less, yeah, resistance. That's it.
Yeah, that's it.
That's it. When you make a short between ground and signal with power on the gauge, what happens with the needle?
It goes full.
Full. No? Indicating that the gauge is good. The problem is probably on the sensor or probably on the sender. No? The most important part in this class, because this is the class of corrosion, is that you be clear that we need identify easily where I have leaks of current. Remember that those leaks destroyed my boat. Those currents destroyed my boat. If I have a boat that is corroded, for sure that boat have a leak. Other symptom is the consumption of the anodes. The anodes are eroded each 2 months, 3 months. You have a leak of current. You need to identify where is the leak. I found it that a lot of bilge pumps, the model of the bilge pump with the time, have a lot of leaks of current.
Well,
we have a lot of examples of that.
Two things that cause that: one, fuel in the boat, like in the bilge,
It'll eat away.
and then not only that, people leaving it on with no water will heat up, and what happens, you'll see it swell on the top. It'll bubble up on the top.
But let me tell you what is the most common mistake on that specific case. Those motors, the motors of the bilge pumps, are encapsulated in the plastic, no?
Plastic.
In this plastic container. What is the plastic? It's in the other side. The plastic container of the pump. And that plastic with the time is broken, and you have leaks of current and leaks on the water, because those pumps are submerged on the water, the majority of them. But the big issue is this, that when the people install the bilge pumps are on the bilge, no? In the bottom of the boat, in the middle of the boat. For the technicians with no acknowledge, it's easy install that bilge pump connected to the bonding conductor, because between the positive and the bonding conductor I have 12 volts. Oh, bingo, finito, I finished my connect. Hey, my friend, this is the bonding. Oh, but I have 12. Yes, my friend, but this is bonded. Yeah, this is a typical pump that is submerged, but the plastic is cracked and have a lot of leaks. This is a perfect example of a pump. But was clear what happened if I connect this pump, the negative of this pump, directly to the bonding conductor? Okay. Suppose that tomorrow we have a storm. What happens with this pump if suddenly we have a strike?
It's going to send that through everything.
This pump explodes
Everything is destroyed.
because the function of the bonding is drain, no? Drain currents. And don't forget, before you, when you have a lot of issues related with the corrosion, with the leaks of current, electrical problems, what is the first step before you enter in the boat?
Check the pedestal.
Check the pedestal. Check the pedestal. Check the pedestal. Take your time to touch the cable with your hands. Touch other cable of other pedestals. My pedestal is hot in comparison with the other pedestal. I don't like that. If you have the chance to remove the cable and verify the color of the look at the neutral here is brown around. That's not good, no? Touch the breakers and measure the quality of the ground in the marina, in the pedestal. How you see easily if the ground is good or not good in that pedestal?
Hot to ground, like you check hot.
Hot to neutral
Yeah, and then hot to ground.
and hot to ground. If the difference is more than 2 volts, that ground is not good. Simple. Hot to neutral, hot to ground. For example, 120 hot to neutral, and between hot to ground is 119.7. So that ground is good. It's acceptable. Oh, 120 and 114, 6 volts of difference. Where are those 6 volts?
In your boat.
flowing, no, on the ground. And those voltage and amps try to enter in the boat through the ground, because I connect the shore power, and now the ground of my boat is connected with the ground of that marina. But I don't have problem because I have galvanic isolator. My galvanic isolator stops those currents trying to enter in my boat. This is the function of the galvanic isolator. Block the intrusion of bad currents coming from the shore power. That's it. Okay, check the pedestal. Normally, when I check the pedestal, I found that a little issues or big issues. After that, enter in the boat and number 1, verify if you have a galvanic isolator. Where is located the galvanic isolator normally?
Right after the plug, pretty much.
Correct. You have the plug for AC power, and pretty close is located the galvanic isolator. Okay, I have a question. If I have a boat, big boat with double outlets, outlet in the port side and outlet in the starboard side, how many galvanic isolators are recommended?
2.
I recommend 2. 1 in pretty close to each outlet. Some people say with 1 is enough. And I say, no, my friend, because if I am connecting my boat in the opposite side where you don't have a galvanic isolator, the bad current travels a lot to pass over there. I prefer 1 in each side. Okay, that's clear. Okay, that's the second step. Verify if you have galvanic isolator, and number 3, verify if the galvanic isolator is good or not good. Because in some cases you see the galvanic, it's over there, but it's broken 2 years ago. It's doing nothing. I am not protected. No, that's very important, my friend. The galvanic isolator, the installation of the galvanic isolator, appropriated according with the recommendation of ABYC, is a good point. The price of the insurance is reduced dramatically if you have a good bonding system and if you have a galvanic isolator installed. This is an important recommendation. Always recommend to your customer that install a galvanic isolator is an important job. Okay, the insurance is reduced, and additionally in the future, if you have problems, you can apply for warranty easily if you have a galvanic isolator. If not, that's difficult. Probably no. Okay, good. You check that. And what is the next step? Yeah, I am verifying my boat, the condition of my boat. Next step is use the church test and verify how is the condition of the wiring in my boat. You remember yesterday we played with this. I recommend check in different outlets, in different outlets on the boat, and verify the condition of the hot, the neutral, and the ground. With this, you read voltage drop, and you read amps, and you read ohms. and this is magic for me. I recommend that. Okay, and also verify that you have in both panels, in the AC panel and the DC panel, and meters. And I recommend, especially in the DC panel, and meters analog and digital, and one of the digitals in milliamps, because with that gauge and meter in milliamps, you can see if you have small currents flowing, especially when everything is off. That's not complicated, no?